Okay, to the stage, Brooke Harris.
Have you ever cooked something and been terribly disappointed when it didn't turn out how you wanted? The other week, I spent hours making creamy Cajun chicken pasta, but as I sat down and took my first bite, I realized the texture of my chicken was off, ruining the whole meal. In situations like this, I tend to limit or avoid my consumption of that food in the future. While this may be a sign that I'm a picky eater, I'm actually not alone in this sentiment. Animals can have similar thought processes as they determine their next meal. Plants, for example, are a common meal for herbivores. With that, they have developed tricks to manage the pesky mouths chasing them. Many plants produce chemical compounds that can change the taste or texture of their plant tissue, making it unpleasant for herbivores to eat, similar to that chicken that just didn't sit quite right with me. One plant that has become very familiar with herbivores is Arizona willow, a rare shrub species throughout the southwest US that is an indicator of ecosystem health and provides habitat for other wildlife. However, this species is significantly threatened due to browsing by elk and deer. I conducted a greenhouse experiment simulating browsing on cuttings collected from natural Arizona willow populations to investigate the chemical resistance and morphological tolerance mechanisms of these populations. This work is establishing an understanding of how Arizona willow persists under browsing pressure. In my data, we're seeing evidence of differing resistance and tolerance defenses across populations. One chemical defense compound appears significantly more common in the Arizona population than in the New Mexico population. At the same time, the New Mexico population shows a stronger shift towards above-ground growth after artificial browsing, demonstrating a compensatory tolerance mechanism as they reallocate resources to regrow what they lost. Together, these patterns suggest that different populations may lean on different mechanisms to cope with browsing, some investing in chemical resistance and others relying on tolerance through rapid regrowth. However, another chemical compound also showed a strong increase in production after artificial browsing across all populations, indicating that all populations do utilize chemical resistance to some extent. By identifying which populations of Arizona willow favor browsing resistance or bouncing back after browsing, we can help guide conservation efforts to protect this rare threatened species. Because for Arizona willow, leaving a bad taste in someone's mouth may be the difference for survival. Thank you.